All right, so now we're going to do some limiting reactant problems. The key with limiting reactant is, remember, it is the reactant that is used up first during a chemical equation. So it's going to determine the maximum amount of product that can be formed. Because it's going to be the first one to run out, it's going to be the first one to stop the reaction, and therefore stop the production of any products. So as with any stoichiometry problem, you need to start with a balanced equation. Remember, on a quiz or a test, equations will be balanced for you, but on this worksheet or any homework type of problems, you will have to balance them yourself. So we just have 6 plus 1 yields 3 plus 2. And then we're going to read the problem. The reaction between solid sodium and iron 3 oxide is one in a series of reactions that inflates an automobile bag. So again, this is just a distractor. Don't really need that info, but it's there. You do need the info on the bottom. If you have 100 grams of Na and 100 grams of Fe2O3, you're going to determine the parts, the questions below. So as with our stoich, right below the substance, I'm going to write how much I have. And notice the main difference between these problems and the stoich problems that we were doing before is you're given 2 amounts. You're starting with 2 amounts. In the stoich problems we did before, you were only starting with 1. So you automatically need to take that and figure out how much product was produced. Now you're given 2 amounts. You have to first figure out which one's limiting, because you have to figure out which one's going to stop the reactant and then restrict the amount of product that forms. So to figure out the limiting reactant, you start by doing something we've done a bunch of times. You're going to take the 2 amounts that you're given, 100 grams of Na and 100 grams of Fe2O3, and you're going to turn them to moles. So you're going to go grams to moles using the molar mass of each. So we have 23 of sodium, and then we have 159.7 for Fe2O3. You're going to divide. You can go ahead and round to 2 decimal places. We did round to 3 when we were doing empirical molecular, but you don't need to do that right now. Notice underneath I'm writing moles of what? And the reason why I'm writing moles of what is so that I can keep track of what each of these are. So it's important to know this is how much you have. This 100 grams and this 4.35 moles represents the same amount. It's how much you have, how much you're starting with, how much you're going to start the experiment with. It's actually physically how much you have. Now what you have to figure out is if the ratio of Na to Fe2O3 is 6 to 1. If you need 6 times as much Na than Fe2O3, you have to figure out, do I have that? Do I have 6 times the amount? So the easiest way to do that is to use a mole-to-mole ratio. I pick the smallest mole amount. That really is kind of arbitrary, but just to keep all of our work consistent, I want everyone to pick the smallest mole amount. I'm going to use a mole-to-mole ratio to compare the reactant amounts. So Fe2O3 goes on the bottom to cancel out, and the other reactant, Na, is going to go on the top. You're going to use the coefficients, and then you're going to multiply 0.63 times 6 to get 3.78 moles of Na. And this represents the amount of Na that is needed. So what this is saying is, if you have 0.63 moles of Fe2O3, which you do, you would need 3.78 moles of Na to completely react with that. Another way to look at it is, this is 6 times as much as 0.63. This is 6 times this. So what you're going to do here is you're going to look at how much Na you need versus how much you have. So you have 4.35 moles, and you need 3.78 moles. Well, 4.35 is greater than 3.78. So since I need 3.78, but I have 4.35, which is more than enough, if you have more than enough you need, then the Na is going to be the one in excess, because I have more than I need. So down here I'm just going to write Na in excess. You don't really have to show your work because you've shown it up top here. So if Na is in excess, then by default, because there's only 2 reactants, Fe2O3 must be the limiting reactant. I'm just going to write it like that. Fe2O3 is Lr. Now what would happen is, there's other times where the opposite happens. So like, for example, this would say 5 moles Na needed. That means you don't have enough, which means Na would be the limiting. But in this case, since you have more than enough you need, Na is in excess, Fe2O3 is the limiting. So now part C tells us what we do with that. We want to know the mass of solid iron. We want to know how many grams of solid iron, which is Fe, do we have. And Fe, if we go back to the equation, is a product. We're figuring out grams of product. This is called theoretical yield. You're figuring out theoretically what's the maximum amount of product that can be formed. This is always going to be your second step here. First you find out what the limiting is, then you figure out how much product can be formed from that. The good news here is it's always the same. You start with grams or moles of limiting reactant, use your mole to mole ratio, and then figure out grams of product. Now since we know the moles of limiting, it's just easier to skip that first step, that first gram to mole conversion, and just start with moles of limiting. You're going to know what it is every time, so just start there. Just start with moles of limiting. I need to change substances to Fe, so I'm going to use a mole to mole ratio. Fe2O3 goes on the bottom to cancel, and what I'm looking for, which is now Fe, the product, goes on the top. The numbers come from the coefficients, so the 2 is on the Fe, the 1 is on the Fe2O3. And then to go from moles of Fe to grams of Fe, I'm just going to use the molar mass of iron. So I'm going to use 55.85 grams. I go ahead and do my math, and I figure out that 70.37 grams of iron can be produced from those two reactant amounts. That's the maximum amount. That's a theoretical yield. Now the last part of this problem is something you may be asked sometimes, sometimes you may not. It's saying how much excess remains after the reaction. So after everything goes to completion, after everything's used up, after the product is made, how much Na is left over. Now there's two ways you can do this, and it kind of depends on what you started with. So what I see here is, in this starting problem, I figured out how many moles I had and how many moles I need. And when you did that for the excess, it makes this problem a little bit easier, because what I can do is just take how many moles of Na I had to begin with and subtract how many moles I needed, or you can think of it as how many moles I used up. And that gives me 0.57 moles of Na remaining. And then just to get the how much, to get the mass, I just take 0.57 moles Na, and I use the molar mass of Na to change that to grams, which is 23. I multiply and I get 13.11 grams. Now the hitch with this one is, this only works if at your start, when you figured out the limiting, that you actually figured out the excess. It only works if you start actually with the excess instead of the limiting. So if that's not true, there is a way that you can always do it. So the way I'm going to do it at the bottom is a way that always works no matter what. It's similar to what we did for part C. You start with moles of limiting reactant, which is going to be 0.63 moles of Fe2O3. Instead of figuring out how many grams of product can form, you're going to figure out how many grams of reactant were used. So I'm going to use a mole to mole ratio to convert from one substance to the next one. And remember, the next substance is actually going to be Na here. Use your coefficients, and then I'm going to take moles of Na to grams using the molar mass. Now what this number is going to represent, when you do all your math, you're going to get 86.94 grams. Now here's the tricky part. 86.94 is the amount used. This is 86.94 grams used. That's not what the question is asking. The question is asking how much remains. So to get how much remains, you're going to take your starting mass minus the mass used, and you're going to get 13.06 grams. And you can see you're going to get pretty much the same answer no matter what technique you use. You're looking for the amount left over. No matter what, when you do an excess problem, you're going to have to do some sort of subtraction. So just make sure you're subtracting somewhere. Either way, it depends on which one you choose, and this is preference. This bottom one will work no matter what happens with the limiting. This one only works if you have these two numbers to start with, if you have what you started with and what you need. We're going to do a few more. We're going to go to number 3. Again, you must always start with a balanced equation. So we're 1 plus 3 plus 2 here. This is a more classic limiting problem that you're going to most likely see. This is more common. It says how many grams of NH3, so I'm going to make note of that, are produced from the reaction if you have 28 grams of N2 and 25 grams of H2. So again, this looks very similar to the stoic problems you were doing before. The difference is you're given 2 reactant amounts. Notice it doesn't even say anything about limiting reactant. It doesn't ask you to calculate it. You have to know if you're trying to figure out theoretical yield of product and you have 2 different reactant amounts, you have to figure out the limiting first, even though it doesn't say it. So again, I'm starting out with my gram amounts of each, 28 grams of N2 and 25 grams of H2. And my first step in any limiting reactant is to turn to moles. And I'm going to turn to moles by dividing by the molar mass of each one. Rounding to 1 or 2 decimals is fine. So I have 1 mole N2. Again, I'm going to keep track of what I have. And then H2 is going to be 2.02 grams. And I'm going to get 12.38 moles of H2. So now I have my 2 gram amounts. I have to compare them to each other. I'm taking the smallest mole amount, which is 1 mole of N2, and I'm going to use a mole to mole ratio to figure out how much of the other reactant should form according to that. So moles of N2 goes on the bottom, H2 on the top. Numbers come from the coefficients, and I get 3 moles of H2 needed. So again, what this is saying is if you have 1 mole of N2, which you do, according to the ratio, you need 3 moles of H2. And I say, okay, I have 12.38 moles of H2. I needed 3 moles. I have more than enough, which means my H2 is in excess, which by default, N2 has to be limiting. One more time. I have 12.38 moles of H2. That's what I got from the problem. That's what I'm given. According to this equation or this calculation, I need 3 moles. Since I have way more than I need for H2, that's going to be the excess, which means N2 has to be the limiting. So once you figure out the limiting here, now it just becomes a stoic problem. So I'm always going to start with moles of limiting reactant, which is 1 here. I'm getting that from right here. I have 1 mole of N2. And I'm going to go from moles of limiting to grams of product. So to switch substances, I'm going to do a mole to mole ratio. N2 goes on the bottom. The new thing I'm looking for, NH3, from the problem, how many grams of NH3, goes on the top. Numbers come from coefficients. Right now I'm in moles of NH3, but I want grams of NH3. So I'm going to use the molar mass of NH3 on the top here, which is 17.04. Do my calculations, and I get 34.08 grams of NH3 are produced. So again, the question's really only asking you for this part. It's only really asking you how many grams of NH3 is produced. But since you're given 2 different gram amounts for reactants, you first have to figure out which one is limiting before you can do anything else. And it may not say anything about limiting, but you just need to go ahead and do that every single time. Now number 4 refers to number 3. Number 4 says how much excess reactant is left over in number 3. So first it's important to figure out, okay, H2 is my excess. Remember, whenever you're doing leftover, how much excess reagent is left over, you're going to do some sort of subtraction. So again, there's 2 ways to do this because I have these 2 numbers of H2. I know I have this much, I needed that much, so I can just take those 2 numbers and just subtract them. 12.38 minus 3 is going to give me 9.38 moles of H2. And then since it wants the answer in grams, I can just multiply by the molar mass of H2, just 2.02, to get grams of H2. That remains. So that, again, only works because in my original limiting reactant calculation, I knew I had those 2 numbers. If that won't work, if you don't have those two numbers available, the one that always works, the calculation that always works, is starting with moles of limiting reactant, 1 moles of N2. And instead of going from limiting reactant to product, you're going to go limiting reactant to the other reactant. So I'm doing moles of N2 on the bottom, the other reactant H2 on the top. Numbers come from the coefficients in the equation. And then I'm going to go to moles H2 to grams H2 using the molar mass. And when you do this calculation, you're going to get 6.06 grams. Now don't forget, if you're doing a reagent problem, if you're doing an excess reactant left over, there has to be some subtraction somewhere. So this is how much H2 is used. You subtract that from the original amount given, 25. To get your leftover. Because again, 6.06 is the amount used. And again, you're going to get 18.94, which is very close to the answer at the top. You do not have to do both of these ways. You got to pick one, and it really matters. You can decide, okay, this one always works, so I'm just going to use that one because it's always the same. Or, okay, this one might be a little easier. If I have the information available to me, I will use that one. Just a quick review of limiting reactants. So steps for LR. 1, you're going to change grams to moles every single time. Then you're going to compare moles to each other. And remember, it's always going to be the reactants using a mole-to-mole ratio. Then on 3, you're going to decide if you have more than enough, that is going to be the excess. And if you have not enough, that's going to be the limiting reactant. And that's really the only 3 steps every single time. Now for the theoretical yield, which is going to be, that's quite sloppy, let me figure that out. The theoretical yield, which is always going to be a product, you're going to start with moles of the limiting reactant. You're going to go to the mole-to-mole ratio, and then you're going to convert either grams, that's most of the time, so I'm going to put a little star, or sometimes it could be liters. You're going to convert from grams to liters. The good news is this is always a theoretical yield step. Moles of limiting reactant, compare it to the ratio, and then turn it to grams or liters.